Again, here is our side, side, side. This is what we use to prove that two triangles are congruent so that we don't have to show both that the angles are congruent and the sides congruent. This theorem tells us that if all you know is that three sides of one triangle are congruent to three sides of another, you automatically know the two pairs are congruent. The reason this is true is because of something called rigidity. These lines cannot be bent. If you think of it, if you had three metal rods of these lengths and you use them to form a triangle, you put them end to make a triangle, those sides are rigid. They can't bend, they can't change. Okay, so if you take those same lengths and try to form any other triangle, it's always going to end up the same shape, and that's because of rigidity. Okay, and it says that three given side lengths determine the unique shape of a triangle, okay, which is basically our side, side, side. Okay, that's why it works. Okay, if you have three sides, you're always going to get the same shape of triangle. Okay, if you have set measurements, and again, that is called rigidity. Remember, the word rigid means stiffness. Okay, these sides are stiff. If they're the same length, they're going to form the same triangle. Okay, looking at this figure, which two triangles are congruent by SSS? Again, we want to find three pairs of congruent sides. So let's look at the markings. So here, this line has one hash mark on it. That would have to be part of our congruent triangle. Find the other side with one hash mark. Okay, it's congruent here. So that's the corresponding side of our second triangle. Find those sides with two hash marks. Here's one here. It would have to be congruent to this line here. Okay, and finally, three hash marks, AD. So here we have one full triangle. It should be congruent to the other triangle with those corresponding sides. Here's our three marks. That makes we have to use this one. So there are our two triangles. We want to name them, and we want to name them in the correct order. The first one we can name in any order we want. Let's try triangle AED. Okay, so AED were the three corners of this triangle. It should be congruent to triangle. Here's our triangle that it corresponds to down here. A matches up with the same position as C, so C would come first in our name. E is the right angle in this triangle. It would match up with E here, and then out to B. Okay, what is an included angle? Well, this is in the wrong section, but we can still talk about what an included angle is. An included angle is the angle included when you form two sides. Okay, so if here is a side of a triangle DC, and here is a triangle CE, the included angle is the angle that's between them, or the angle they form. So angle C would be included between the side DC and the side CE. Okay, so let's practice that. So given lengths AB and BC, which angle is in their included angle? Okay, so let's outline those. Okay, so AB and BC. What angle is included? Basically, what angle do they form? They form this angle right here, angle B. Or if we write it more formally, angle ABC. One other hint that can kind of help you out here is, notice this is the letter that was repeated in both. That's the angle where they come together and the included angle. So I could have just looked at their names and seen the included angle would have been angle B, or angle ABC. Hey, here's another one. Given lengths AB and AC, what would the included angle be? So just looking at their names, what do you think it's going to be? Angle A, angle B, or angle C? Well, notice they both share the letter A. That means that's where these must be connecting, and that must be the vertex of the angle they form. So right away I can tell it's angle A. If I look at the picture to tell, I want AB and AC. Okay, what angle do they form, or what angle is included in between those two sides? Angle A, or angle BAC, if we want to write it with the 3 letters. Okay, given lengths BC and AC, which angle is an included angle? Okay, so let's identify those. Let me clear my screen real fast so we can, or my triangle, so we can see. Okay, so again, we're looking at BC and AC. Looking at the name, you should be able to determine the included angle. It's the one that they share, C. Looking at the picture, you would draw those lines, so BC and AC. You want to be the angle to be the one that's squeezed in between them right here, which notice is angle ACB. I can't call this one just angle C because notice there's another angle located there. All right, and for triangle ABC, what type of angle is DCB? Okay, what is that angle called? Now, some people may have said, oh, it's obtuse. What we're talking about here, notice here's my triangle ABC. What did we call that type of angle that if you extend the side and it's outside of the triangle? That's what angle DBC is. It's in the exterior. So remember, that was called an exterior angle. So just a kind of a review there. So for this triangle, angle DCB, the angle located right here, is an exterior angle.